Discuss capacitors in series and in parallel. Capacitors in series. The circuit in which all the capacitors are connected one after another in the same path so that the same charge or current flows to each capacitor is called capacitors in series. Consider three capacitors C1, C2 and C3 are connected in series with battery of potential difference V. The Kirchhoff's second rule gives voltage V is equals to V1 plus V2 plus V3, where voltage V1 is across capacitor C1, voltage V2 is across capacitor C2 and voltage V3 is across capacitor C3. The charge Q of capacitors connected in series is common to all capacitors. The equivalent capacitance C equivalence of three capacitors connected in series is given by Q divided by C equivalence is equals to Q divided by C1 plus Q divided by C2 plus Q divided by C3. So Q gets cancelled and equation becomes 1 by C equivalence plus 1 by C1 plus 1 by C2 plus 1 by C3. Therefore, for n number of capacitors connected in series, the reciprocal of equivalent capacitance C equivalence is equal to the sum of reciprocals of capacitance of the individual capacitors. So we can write 1 by C equivalence is equals to summation of 1 by Ci, where I is equals to 1 to n, where I is equals to 1, 2, 3, 4 and it goes up to n numbers. Similarly, when capacitors are in parallel, the circuit in which all the capacitors are connected side by side in different paths when the same charge or current will not flow through each capacitor is called parallel capacitor circuit. Consider three capacitors C1, C2 and C3 are connected in parallel with battery of potential difference V. When a voltage is applied to a parallel circuit, each capacitor will have different charge. The capacitor with high capacitance will get more charge, where capacitor with less capacitance will get less charge. So, the total charge Q is given by Q is equals to Q1 plus Q2 plus Q3, where Q1, Q2 and Q3 are the charges on each capacitors C1, C2 and C3. And charge is given by C into V. Therefore, equation becomes C equivalence into V is equals to C1V plus C2V plus C3V. Here, V gets cancelled and equation becomes C equivalent is equals to C1 plus C2 plus C3. The equivalent capacitance C equivalence is equal to the sum of capacitance of the individual capacitors when n number of capacitors are connected in parallel. So equation becomes C equivalence is equals to sum of Ci, where I is from 1 to n numbers, or I is equals to 1, 2, 3, 4 and it goes on up to n numbers.